Alright, so this video is about Chapter 9. Yes, we skipped ahead a little bit because we're only in Chapter 6, so we're skipping ahead to Chapter 9. We'll go back to 6 and finish it out a little later. So, Chapter 9, Sequences and Series. Alright, sequences. What is a sequence? Okay, a sequence is a list of numbers that follow a pattern. Okay, there are tons of sequences. Tons. Alright, but there are two basic types. Your first basic type is an arithmetic series. I know that looks like the word arithmetic, but it's actually arithmetic. It's where you add or subtract by the same, important word there, same number every time. Okay? An example would be like, say 1, 2, 3, 4, 5. I'm adding 1 each time, or 2, 4, 6, 8, I'm adding 2 each time. Next kind is a geometric series, or sequence, sorry, because this video is on sequences, we'll do series a bit later. A geometric sequence, it's where you multiply or divide by the same number every time. For example, 2, 4, 8, 16, 32, and so on. We're multiplying by 2 each time, or 3, 9, 15. I messed that one up. Alright, so it's where you multiply or divide by the same number every time. For geometric, arithmetic is you're adding or subtracting by the same number every time. And that's the key word. Okay? Arithmetic, think of arithmetic, you're adding. Okay? Geometric, you're multiplying or dividing. And it's the same number every time. Okay? Alright, in this video we're going to concentrate only on arithmetic sequences. Alright? So, here's an example. We have 1, 4, 7, 10, 13, and 16. Alright, so we need to figure out what our series is. Well, you can pick any two numbers and just subtract the higher one and subtract the one on the right from the one on the left. So 10 minus 13 is 3. So that means difference, or D, equals 3. Just verify that between all the rest of the terms, and it is in fact an arithmetic sequence because we're adding 3 each time. Now, in our arithmetic sequence, the first term is a sub 1, second term, a sub 2, and so on. Okay? So, if you notice, to get from a sub 1 to a sub 2, we added D one time. So, add D one time. Alright? To get from A1 to A3, so now to get from A1 to A3, we had to add D 2 times. Alright, and to get from A1 to A6, we had to add it 5 times. Okay, so A1 to A6, let's see, 3, 4, 5, so to get to the last number, A6, we had to add D 6 times. So if you notice, we're always starting with the first number. Okay, we're always starting with the first number, and we're adding, how can I say this? We're adding 1 less, like this is a sub 6, so we're adding 5 times D. Okay, let me write that in the formula. So if you wanted any number n from this sequence, say I wanted the 400th term, what we're going to do is we're going to take a sub 1 and we're going to add n minus 1 times D. So if I wanted the 400th term of this, a sub 400 would equal a sub 1, which is 1, plus 400 minus 1 times D, which in our case is 3. Alright, so this would be 399, because 400 minus 1 is 399. So 399 times 3. It's going to be 1 plus 1197, which is 1198. So if we wanted our 400th term, it would be 1198. All right? Now, let's look at another example. Here we have a sequence 70, 66, 62. And we want to know what is the 200th term of this sequence. Okay? Well, you just use the formula I just gave you. A sub 200 equals your A sub 1, which is 70, plus 200 minus 1 times D. But now we have to figure out what D is here. Okay? Well, if you notice, if you subtract this term from this term, you get negative 4. D equals negative 4. So that means we're adding negative 4 each time or subtracting 4 each time. Our difference here, though, would not be 4. It would be the negative 4. Okay? It would be the negative 4 because our number is getting smaller. That's why I say take a number and subtract the 1 from the left, because 62 minus 66 is negative 4, and that's what D is. Okay? You can't take the absolute value of it. You have to take the negative. So this is going to be 70 plus 199 times negative 4. 199 times negative 4. Okay, so that equals 70 plus negative 96. So 70 minus 796. So our 400th term, or 200th term, sorry, would be negative 726. All right, it's okay that it went negative because, as you see, if we keep subtracting from this, eventually it is going to go to a negative number. So it's fine that our 200th term is A sub 200. It's okay that our 200th term is negative because if you're subtracting, eventually you're going to go into negative numbers. Okay? Now let's do one more example. Here we have a sequence. We don't know what the first term is, but we know the 6th, 7th, and 8th terms. Okay, we know the 6th one is 15, 7th one's 20, 8th one is 25. We want to figure out our 42nd term. Okay, first thing, figure out what the difference is. Well, 20 minus 15 is 5. So, and then 25 minus 20 is also 5. So our difference is 5. Okay? But if you notice, if we went from A6 to A7, that's kind of like one hop, so to speak. Right? Because if you went from here to here, that's one hop. From here to here is 2 hops. Okay? And of course, 7 minus 6 that's only 1 hop. Okay, that's how I figured it out. Whoops, 7 minus 6 is 1 hop. To go from A6 to A8, that's of course 2 hops, because 8 minus 6 is 2, so that's 2 hops. Okay, so here our formula is going to be a little different. Okay, because we don't have the first term, so we can't use the previous formula because we don't know A sub 1. All right, but A, in this case, A sub M, M is the term you're looking for. Okay, M equals term you're looking for. Okay, A equals, and this is going to equal A sub N. In this case, A sub N is the first term you have. Okay? First term you have. Alright? And that's going to be plus M minus N. So you're figuring out your number of hops. Okay? Term you want minus the first term you have. And then you're going to multiply that by D. Okay? So let's plug in some numbers and actually figure this thing out. A sub 42, because we're looking for a 42nd term, equals A sub N, which in this case is our first term we have, so it's 15, plus, okay, we're going to have to do 42 minus 15 times 5, because that's our D. Okay, 42 minus 15 is 27. Okay, so that equals 15 plus 27 times 5, because 42 minus 15 is 27. Wait, I'm sorry. Messed up right there. It's not minus 15. It's, the first term we have is our sixth term. Okay, so it should be the number of the first term you have. Number of first term you have. So a sub n, that's a sub 6. Well, a sub 6 is 15. So here we're going to do 42 minus 6. Okay? Sorry about that. And 42 minus 6 is 36. And then, of course, times 5, because that's our difference. You just bring that down. So this is going to equal 15 times 180, which is 195. So our a sub 42 equals 195. All right? So make sure you have the two formulas I gave you written down. The first one was this: a sub m equals a sub n plus m minus n times d. Remember, m, it's the number of the term you're looking for. We're looking for a 42nd term, so m is 42. And then a sub n, remember, n is the number of the first term you have. The number of the first term we have is a6, so a sub n is a sub 6, which is 15. And then, of course, times d, which is your difference. All right? The second formula you should have written down is this one. A sub n, which again, n is the number of the term you're looking for, equals your first term plus the number of term you're looking for minus 1 times the difference. All right? So make sure you have those two formulas written down and make sure you know how to use them. All right? So you can watch this video as many times as you need to. Just be ready to work some problems tomorrow. See you tomorrow.